Hey everyone, welcome to another Common Lisp study group. With I'm your host Ram Vedam with Atlanta Functional Programming. Um, Sorry for my tardiness today. Just a couple of technical difficulties that I need to take care of, and we were getting a little sidetracked on setting up the stream. um, Today we're going to be talking about Pandoric macros, which I when you read about it, you'll end up kind of like wondering, well, this is kind of nice, but it really kind of shows how you would end up leveraging, the Common Lisp object system and how some of its features are used to write like generic methods while introspecting your objects themselves. Um, so I thought I'd start with that, like because the book kind of mentions it a little bit. He starts by talking about a very nice book on Lisp system implementation, Lisp in Small Pieces by Christian Kienek from France. In there, has with a lot of Lisp implementation books at that time, and even today, Christian Kienek goes through and stops at a nice implementation of an object-oriented system inside Common Lisp. And actually, I think that one was in Scheme called MeruNet. And he was trying to show off an example, something along the lines of like if you had like a point class, you could can everyone see my screen? Those who are on the chat.
I mean, I can see your screen just fine on the stream. I have it up on my iPad.
Oh, okay, cool.
On the Hangout, it would be good if you actually were sharing your Emacs instead of your OBS window, though.
Ooh, okay, wrong one. 1 second. I thought I was sharing the wrong one. Okay, stop screen share. Emacs. There we go. All right. So, if I recall, his implementation was something along the lines that if you had a point class, it would be kind of nice inside Scheme to be able to write something where if you write, let me actually pull that up just a second here, so I don't get it right. Yeah, you have something like double where you have a point here, and this will not work in inside Common Lisp, but I'm just showing it to you for the sake of example. You want to be able to set the member variables of this point class, this point instance, sorry, with their appropriate instant variable names that are inside the class. And one of the things that he points out is in Scheme, and I don't know if this is necessarily true today with Racket. So those of you who are familiar with that, please correct me if I'm wrong. There is no way inside either Scheme or newer schemes where you can actually do a reflective check to see what members are instant variable members are of a class and use those variables directly inside forms within some sort of lexical scope. So like the example that Common Lisp did to solve this problem is with this with slots, which we've seen in the past, but I thought I'd at least bring up an example here of how one could use with slots, which basically goes in, as you can see, into the object instance, looks up its instance variable, binds it to this local variable instance, a year in school, and then uses it in forms inside of the method. Now, this kind of introspection is only possible inside Common Lisp and the Common Lisp object system because of the kind of reflection utilities that are available inside of the language and how it built up its OO infrastructure. But as it turns out, and this is what Doug Hoyt was trying to get at inside Chapter 6 on Pandoric macros, you could use the same kind of technique in closures when you're doing closure-oriented programming, as he's been kind of illustrating throughout this entire book, which is a lot of techniques on leveraging closures really to really build up not only objects but different ways of writing macros and macro generation. So one question I have for some of the more experienced people who probably looked through this book and saw this section is so we start talking about symbols in D lambda here in the beginning, and we go into some stuff that we talked about earlier on about anaphoric macros, where we actually are using the anaphoric reader macro here later on to actually bind our environment. But the notion of a Pandoric macro, as I understand it, is it creates a new environment on top by opening up a closure in a new lexical environment that you could then access its internals, but you're not trying to kind of like leak out that information outside that new environment. Is that kind of like, a good way of explaining?
Sure. Sure, kind of. I mean, a good way to think about it, I think he mentioned in the book, is it's sort of like an extension to lexical scope. Whereas, like, normally lexical scope can't cross over function boundaries.
Okay.
With Pandoric macros, you can.
But you're getting a new lexical scope, though, right? You're not actually leaking it into like the global. The symbols are not.
Oh actually... yes, it's a new lexical scope introduced by the symbol macrolet.
Okay.
But it's done with anaphora, which makes it seem like all the same lexical scope.
Okay. All right. So he goes through a couple of things. Like one thing is for the extension piece, it's this let binding, this sublet let binding transform that he created that that we're gonna kind of look at for folks who are looking at my Emacs buffer right now. I just brought out some of the anaphora and some of the macros that we're going to be using to implement this Pandoric macro called Pandoric let, and that will generate the new lexical environment that the closure is going to be opened into. So this new extension is going to be opened into that way. So this let binding transform, all it does is it's a function. It's not actually a macro that goes through and kind of generates a set of let bindings using given a list, and it makes sure that it if we actually run this guy. Let me just first change into that. If we actually, this also handles kind of like this case where if we do b, I think it was nil, it will actually return. Yeah, it'll go through this nested structure, and each nested structure, like here, A is kind of like one thing, and then B is being set to this empty list with nil in it. It'll go through and make A into its own binding and B into its own binding. This is useful for later on when we start actually going and opening up the actual closure with the Pandoric let. Now, in the book, when you if you guys are reading through it, he kind of goes a little bit out of order. He shows you Pandoric let first, and then shows you how the accessors are going into it. It took a little bit of time for me to at least like look at all the code. So I put it in the order that I thought it was kind of made the most sense. So Pandoric let get and Pandoric let set, what they do is they're able to go into the closure and grab a particular symbol from that closure, and then allows you to manipulate it based on certain arguments that you're going to pass into. Of course, these two accessors are not used by themselves without you actually using Pandoric let, which what it does is it creates a new closure here. As you can see, it takes the let args, uses the let binding transform to actually create the environment, and then it creates this new closure right here in this code generation that it's actually specifically a let over D lambda, which if you recall from our previous a couple episodes ago, D lambda basically allows you to essentially create a closure, another closure that takes in an argument, and based on what you pass into the argument, which this case statement here creates, it'll then call the appropriate function that you've you set inside the do lambda, and that's what happens here. So Pandoric get, if you pass in Pandoric get and you take in the symbol, it'll go ahead and call in Pandoric get and Pandoric let set accordingly. So let me show you how this is kind of used, and then we'll talk about with Pandoric in a minute. So let's say that we create an accumulator here. This is just a simple counter that starts allowing you to, add in accumulation. If you pass in, sorry, I just had that. You pass in some sort of initial value. Initial value is set to 0. You pass in a value, it then goes ahead and increments it. I mean, this is nothing, spectacular here. But one of the nice things is you can then do pan test, Pandoric get ACC, and you'll see that we can actually retrieve the accumulator as well. And in fact, we can actually reset it to a different value with Pandoric set. And we could set it to a different value here, and now you could see that when we call, pan test with 5, it'll go ahead and, apply that closure, that accumulator, add that 5 to the accumulated new accumulator value of 100 to get you 105. But what this also gives us is this ability, and I think this is pretty cool, which is you can actually get the closure that is pointing to this internal variable. So internally, you now know what this closure is. Now, I didn't see any examples in the book doing this, but I think you can actually change this too, right? To be a different value, right? You can actually change this to be a new lambda, if I'm not mistaken. So if you do Pandoric set this lambda, let's see, this would take a value n, and instead of incrementing, we multiply, ACC with n. So
the problem there is that you don't have access to the actual closure inside that set there.
Okay, so if you're saying, are you saying that if I try and calling this, okay, so I don't have the actual internal variables inside of it. So once it's set,
because pan test is just a function.
Right.
It doesn't bind anything. It doesn't expose the lexical scope. It doesn't expose the closure.
Right. Okay. So that's where the hot patching stuff he brings up later kind of comes in. If you want to use a new function, he gives this nice. Well, we'll get there too at some point. So there is this nice thing. Let me go back and actually reset this guy.
Yeah. You can't.
Yeah,
you have to reset it by recompiling the thing over on the left. Yeah,
I got it. Okay, cool. So now we have these two nice functions for what he calls the what was it? It was the some interclosure protocol for getting symbols inside of the syntax. I don't know why he called it this, but it's kind of interesting. And here, you have these two functions. One, obviously we can call given the object that we're trying to get in the closure, we can actually grab the symbol from that closure. So if we try running this guy, actually let me do that and that, and we then run, say, get Pandoric on our pan test guy. You can see that this does the same thing as us calling Pandoric get directly on pan test as we did earlier. But there's also this nice little thing here, and this introduces something that I don't think on this stream we've ever introduced, which is def_setf. Def_setf basically creates a new, I think it was a macro when I looked this up.
Yep.
It creates a new macro that then generates this code.
It's like a macro. It's called a setf expander.
It's a setf expander. Okay, so is this the same thing as if you did what is it? It was, I think, defund setf. Oh, dang it, I'm forgetting the syntax now.
Yeah, get Pandoric.
Okay. Get Pandoric. Yeah, get Pandoric. And then we could then pass in.
Val comes first.
Okay, val comes first, and then box and sim, like that.
Yep.
Okay.
Yep.
All right.
It's not exactly the same thing because with the get Pandoric, the code gets inlined because it's a macro.
Right.
But you could implement the same behavior in this case using a setf function. Yes.
Okay. Cool. And what this does is this actually gives us the ability to now setf, use a generic setf, like a generalized variable is what they call it, and then do get Pandoric and pan test ACC, and we can set this to a new thing, and it's completely a different accumulator. So these are still all environment stuff that we've kind of talked about now, and this setf expander is basically what creates the generalized variable notion that he brings up in this book. I honestly, until I read Let Over Lambda, I don't remember ever seeing that phrase being used for this kind of pattern, this generalized variable.
Generalized variable is the standard term for it, actually.
It is.
As an alternative to place.
Okay.
Generalized variable and place mean the same thing.
Generalized variable in place. Okay, I've heard place, but I never. Okay, got it. All right. The other thing that he brings up is symbolic macros. Symbol macros. Symbol macros, I think we've touched a little bit on with symbol macrolet. To give a quick example of this guy, I think the book that I think it's somewhere I've seen he did symbol macrolet. If you do hi, I think this is the one straight out of on Lisp actually. This is where you can do print hello. Actually, let me do this. Prog_n. I shouldn't use prog_n, but I'm gonna, for the time being, use prog_n. Do 1, and if you do plus, hi 1. This thing, if you run it, you'll see that it'll actually, for some reason, it didn't actually print out 2. Should have actually printed out 2. But
it wouldn't print out 2 because you don't have to print that.
Yeah, I got to do that. Yeah, that's what I'm going to do. Okay, so here you can see what it does is it expands the macro, evaluates the form, returns the last value, and then actually ends up that last value is then what's used in the final S expression there for adding 1 to 1. We use this specifically to create symbols inside with Pandoric for our environment extension. Now, this is where things are going to get a little murky. Now, if you guys look at the book's way of doing it, he uses his own syntax.
Can I take us on a very short detour?
Yeah, sure.
Do you guys remember? Like a slot value? We talked about it earlier.
Yes.
So slot value is also implemented in terms of symbol macrolet.
Oh.
Yes. That's how slot value works. That's why you can setf a slot that you create that you have access to via slot value.
I did not know.
If you macro expand a with slots form, you get a whole bunch of symbol macrolets.
Ooh. Okay, hold on. I think I have an example here. Let's go through that example right here. Okay. Let me do this. Ah. Okay.
Yep.
Okay
Simple macro let year in school is really slot value thingy quote year in school.
Got it.
And that actually will look really familiar to you once we get down to generating the Pandoric bindings in, what is it, with Pandoric?
Yes.
Yeah.
Yes.
With Pandoric is more or less with slots. It does basically the same operation.
So this is my attempt of trying to max to generate his def macros bang, because he has that O bang and G bang symbol stuff, and the G bang stuff was fairly easy, but for the O bang stuff, I was like, I think it's just another layer of with gensims. So
No, you need a once only.
I need a once only. Okay.
And that whole thing is not going to do what you want it to do, actually. Now that I'm looking at it more closely. Can you re-indent that code?
Okay. I don't. Okay.
Yeah, run that in your REPL. See what happens. Like, copy that code over to your REPL.
Oh, you want me to copy it? Okay.
Yeah.
By the way, just a small detour. There was some extension that you're using in your Emacs that allows you to like write like proper indented stuff inside the Sly REPL. Do you know what that extension is? Is that in Common Lisp Sly?
Well, I mean, it's just applying that indentation to it.
Yeah, I just use the indent key. Part of what it is that evil binds the equal sign operator to be re-indent.
Okay.
And so I just do that. I just equals percent on whatever I need.
Okay. So this is me running with gensims, and it generates this macro here.
Yeah, you're just generating code.
But hold on, let me try and grab that example from the.
So my point is that what you're doing there doesn't actually define a macro.
It doesn't.
No, it just generates a bunch of code.
Oh shoot. Okay, that's not what I want. Okay, clearly that is not what I want. Okay. I thought that would actually get evaluated. Okay, so this is wrong, clearly. Okay, I'll just go ahead and re-indent this. Okay.
There you go. Yes. And the comma O box is not going to help you.
Yeah, that's right.
And basically, what you need to do is the outermost thing in the body of that with Pandoric, you want to use a once only. Alexandria's once only macro.
Okay.
Can everybody hear me?
Not wrapping the with Pandoric inside the macro, but around the body.
Okay, got it. Okay. I can hear you. Whoa. You have a.
Oh, you can?
Yes. Can you hear
me?
Okay.
I was having some audio difficulties. I had to restart
the
system here.
A once only. I'm guessing I just have to put box here. Comma O box. No, just
no
O box.
Comma. Yeah.
There we go. That's what I needed.
And then re-indent that.
Yeah.
Yeah, that's all kinds of wrong. That's not indented right at all. I think you're missing a close paren.
Yeah.
Let's see here. You are. Whoa.
Yeah, I don't really know what's going on there, but there's something that's very broken.
Okay, you know what? I'm gonna just rewrite it. Yeah. Okay. With Pandoric. Sims Gbox. For some reason that I have all the right parents, I can see it because it's compiling, but it's not indenting right. A once only. O box. O box. Okay. A with gensims.
Skip that with gensims. I don't.
Yeah, you don't need the with gensims.
Do I not? I thought I did.
No. No.
That's because there's another.
Well, so his def macro bang does a with gensims as well, but once only is doing that for you.
Okay, so then I could just do this. Gbox then.
No Gbox there either.
You don't need a gensim at all.
Yeah.
Okay.
Gbox is the gensim that's generated by Obox.
Really? Hold on. Let me go look at that.
His def macro bang.
Ah, okay. Got it.
So you just need a simple macrolet and body inside that. That should be the whole Pandoric macro. Or
Yeah, the with Pandoric.
That's correct.
You know what I bet it is? I bet it's the hash backtick reader macro.
Yeah, more than likely. Now that I think about it.
Hey Ram, I would suggest checking out the Emacs package aggressive indent.
Aggressive indent. Okay.
After the stream.
Got it.
Yeah.
I will.
Keeps everything nice and indented properly as you're typing, all per character, per keystroke, just so you're not losing your mind. Just to make sure it's all indented properly and you got the right syntax and everything. Pretty useful.
And that, and I think it's just that body here. All right.
Yep, that looks right.
Let's see. With Pandoric.
Oh, the stupid sharp back tick.
Yeah.
There is.
Throws me off. I just use Serapium's op.
Yeah.
Okay, you know what? For the sake of my sanity, from now on, I'm just going to use that too as well. All right. S-op.
Backward.
Backward.
And then replace the A1 with an underscore. Underscore 1, actually.
Underscore 1 has to be this time.
Yeah, comma underscore 1.
Oh, comma underscore 1? Okay, got it.
Yep.
And then basically just go over there and replace the A with an underscore.
Got
There
it.
you go. And
Quote, comma underscore 1. Yep.
Okay. Let's go here and do the example, which is the same thing with Pentest. Okay.
Oh, I might see a problem. I might see an issue here.
What issue?
Just so. 1, 2, 3. Oh, never mind. I was reading it wrong. It looks perfectly fine.
I was like, what? All right. I mean, I knew that I didn't realize that that reader macro really kind of messes things up, kind of surprisingly.
It can, yes.
Yeah, and it also
Reader
makes it
macros
look like a
can-
function object at first glance.
Reader macros can really screw with stuff.
So this is an example of the use of this with Pandoric macro, which is basically with slots. Let's go and expand this guy. Let me go and put this back in an Emacs buffer here. And that way I can actually use MS. You can see here what this does is okay, now I see what you were saying. So that O-bang box basically creates what's passed into G-bang box in his thing. I misunderstood. I thought he was creating two different gensims.
Nope.
in that
Yeah, that's
thing.
just how his def macro bang works. You
Yeah.
use the O bang in the args list, and it makes a G bang symbol for you in the body.
Okay. Oh well, in that case, I could have also used with gensims there, couldn't I? And
No, because the once only does also make sure that the thing that's passed in at that argument gets let bound once in the actual expansion, so it's only evaluated once.
Okay, got it. So I still needed once only, even though.
Yes.
Okay, got it. All right. So in this expansion, it basically binds to the symbol function, the closure. Then it calls get Pandoric here, which I think is just the inline function, and then grabs the accumulator and then returns it. Okay, got it. Okay, this is cool. I'm with this. Now he added a couple of other things in here. Now this is basically the gist of the Pandoric macro, but he also added a couple of other interesting things like on top of it, like hot patching, where if you wanted to use what I was saying earlier, um, where the possibility of creating a new function or changing the function inside the closure, you can use something like. Hold on, let me first delete this guy because this is wrong. All sorts are wrong. Ah, dang it. Hold on. Let me grab that again. This guy basically allows you to go open up the closure, and it really just sets this variable, which is in the case of pan test, in what would be running example that we've been using. It will set it to a new function that it was originally there. So let's compile this guy. Notice this is not a, for folks who are watching the stream, this is not a macro, this is an actual function. Just want to bring that up because when I looked at it originally, I overlooked that and I ended up writing this as a macro. So I had to go and correct that.
Hey, Elijah, should it be an error if Hotpatch? Oh, the version. Never mind. I gotta inspect my code a little bit.
Should it be an error? What do you think?
Nothing with this. My Hotpatch code differs a little bit from yours. There might have been something I did.
Okay.
Or just something in a later part of that chapter that I didn't.
So this guy, we start with, let's go in and, set this to like, some variable like 5. Okay. We can actually now go in with this hotpatch function, hotpatch guy. Now that we've had this compiled, hotpatch. We can actually type today. Hand test. We can actually now set this up. So why is it always putting it?
Because it's just a function.
Oh. Okay, got it. Let's set this new. We're going to create a new closure.
You need an extra pair of parens there.
Oops. Yes, I did. I need that. No. Hold on. There. We can now, create a lambda that will now decrement this guy by a certain value. So technically, actually, I'm kind of curious, without this hot patch, if I created a new closure, would that have actually worked, what I did earlier, since it was bound?
It would have worked as well as what you're doing now.
Yeah. Because this hot patch isn't necessarily needed, but it does clean, with Pandoric, it does clean up the code a little bit. So I was just doing it wrong earlier. So we now have two different ways.
Actually change things in the way you'd think, though.
Let me just try something here. 5.
Oh, I see what I did. Oh, jeez. I named my Hotpatch macro, or I named his recode
Set
macro
this.
my Hotpatch macro.
Oh, yeah, I forgot.
This.
Yeah. Now this, okay. So now if I do 5, okay, this should have. Now this one, if we go and call now pan test 10, people can go ahead and decrease it. And Elijah, you mentioned something that this isn't working the way I'm expecting it to work.
Check the value of accumulator using Pandoric get.
Okay. Oh. Okay. Got it. So it's not completely there. There is something that's missing.
There's no way to do that without actually using with Pandoric to get the actual accumulator from the Pandoric macro.
Right.
When you create the lambda.
Right. So this is so when so that means I have to go and re-inject. So this ends up becoming that new macro, which he calls Pandoric recode. That's why Pandoric recode is necessary, which is so sometimes you want to be able to actually go in and replace the entire guts. This is actually replacing the entire guts. You're doing a recode of the entire thing. Box new, I think is what he says. Yeah, hard box new. Then we do with Pandoric on the vars, the box, and then we just do, oops, forgot something here. Set Q, this,
Set F.
Set F.
Okay, I'm sorry. This is, I wrote this down straight from his
Yeah,
notes.
it's not your fault, it's Doug's, but set F.
I have to get used to that. Just, when I write my own code, I use set F. When I see his code, I just go back to using set Q. So I just need to remember that it's always set F. Okay, so now if I go in and actually do this, and actually, let me just go ahead and copy this guy. And just replace this guy with a recode, and I'm forgetting how we end up. Yeah, we do this. Now we can actually get rid of this guy and just simply use. I think that's all I need to do. Yeah, this is it. So give me a second here. Need to re-indent here.
Got an extra parenthesis there.
Yeah, I noticed that. Yeah, I'm noticing.
My recode.
Nope,
macro
that's
is
the
slightly
correct
different.
indentation for that.
Yeah, that is the correct indentation. Okay, so now if I run this guy on Pandoric and do set 10, you see that it's -5, and if we actually go and grab the accumulator, it's actually getting properly updated. So what we did internally is this accumulator value is now a new value in memory almost, right? It's basically, or is it the same value that we just opened up and
Actually,
changed?
you've kept the accumulator, you've just changed the function.
Okay, so the function is brand new, but the accumulator is still the same. Okay, so we basically replaced. Okay, I got it. That makes sense.
And that has to be a literal lambda, by the way. You can't, like, have some function you've defined elsewhere that just goes, that uses ACC, and then just use it in that body. You have to actually have the literal lambda expression be in the body of that macro.
All right.
Otherwise, it wouldn't be able to see the ACC.
That makes sense because that lambda, that defined function, that named function created its own. Well, it will be an unbound variable, but it will have its own lexical
Correct.
environment with its own ACC variable.
Correct.
Right. Okay. Cool. That makes a whole lot of sense. But I hope folks can actually see that this actually makes things pretty cool because you can actually now, depending upon the situation, go and introspect your objects. Now, I'm not saying that it's good practice in some production code situations, all right? Don't go use this willy-nilly because that could lead to like state changes that make things debugging a little bit difficult. At least I could totally see this make state change it being a little bit difficult because you'd have to go and internally figure out, well, what the hell does this closure actually represent at this current point in the execution? But it does have its uses.
Inspect the actual pan test object.
Okay.
Do hash quote pan test.
Hash. Wait. Quit. Okay, you said hash quote pan test.
And inspect that.
Okay. Inspect star.
Just hit enter on it.
Oh. Okay, got it.
Don't get the names, but you do get the values.
Yeah, you do.
Closed over values, 0 is the accumulator and 1 is this.
And this is just a closed code, but it is referencing the lambda n from that source code. Okay.
That is the lambda.
Yeah.
Right.
Okay.
And it's closed over the outer lambda.
Right.
Because closures and cycles.
So with all these new pieces, we can actually write our Pandoric let has another macro which he calls. So Michael, I'm gonna let you like kind of chime in here a little bit because I think you understand this a bit better than I do, which is his PLambda macro. I'm just going to first kind of paste this because I'm trying to see. I still don't quite understand the difference between this one and what is it? This one and Pandoric let exactly. So because it looks kind of like the same thing.
Let me try to remember this. I'm looking at the code. The difference between that and plet, you said?
Pandoric let. Yeah. Mm-hmm.
Yes, yeah, okay. So, Pandoric let creates new variable bindings, whereas PLambda actually, its Pandoric bindings come from the enclosing scope. It captures them.
Okay. Okay, where I'm trying to look at this. Where is it capturing him here in this on line 140? The let here. I guess.
No, so you see the Pandoric get Pandoric set bit in the D lambda.
Yeah.
See how it does Pandoric get p-args there?
Yeah.
Pandoric let get p-args?
Mm-hmm.
Since it's never actually in the Pandoric let up higher up, it actually creates new bindings named for each of the p-args.
Oh,
right?
Okay.
But since it doesn't do that here, when it defines the getters and setters, they reach outwards to bindings that are in the enclosing scope.
Got it. But that's what this is doing right here, right? Because PRs is being reset here.
Time. That's a compile time.
Okay. Hold on, let me just run it. Okay. Let me try and see if I can. Let me grab this guy here. Okay. So one example.
I can give you two different bits of code that show the difference. Well, I mean, yeah, that works.
This
that
one.
Right there works.
This one I think kind of works. So
you only need one let there.
Yeah, I noticed. This guy can be. Hold on, let me just make sure that I got. Oh, it's B1.
Yeah, B1.
Okay. Okay. This is gone. That's gone. I'm going to go and re-indent this sucker. Okay. So we create a single closure here, and then we grab the list of p arguments here. These are from this parent scope.
Yep.
And then we add. Okay, got it. We increment a by n, and this is just our lambda function here.
Right. You could rewrite this using Pandoric let pretty easily. So go ahead and copy that.
Okay. And this is, I think if I just change this guy to Pandoric let and then add the lambda.
Yes, more or less.
And then here, this is, and then I need to slurp, I think the next expression. Capital S? No, not capital S. Hold on, sorry. S. There we go.
Yep.
Lambda and
then you need to remove the n from the Pandoric let, and then add the 0 and the 1.
I'm sorry, I had to take off for a couple minutes if you were asking me a question or something, unless Elijah got it.
Okay. And add a 0 and 1 where now?
On the Pandoric let. You don't need the let surrounding the Pandoric let.
Oh, got it. Okay. Got it. Okay. You're saying this guy needs to be set to 0.
Yep.
No. Undo. And then this guy needs to be set to 1. Okay. I think this is right.
Yeah, and re-indent that whole thing. That cannot be right.
It looks like it is, but I can always,
That cannot be right.
What are we trying to do here?
Oh, we're trying to basically, you see this PLambda? We're trying to convert this into a Pandoric let to show the differences.
Yeah, but the indentation of that lambda is entirely wrong.
Yeah, as usual. When I go and modify crap, it's always
What the heck?
I'm telling you, my Space Max has like some sort of like spirit.
Okay. Listen to my exact key binding. Stop moving your cursor. It's 0. K. 5L. 3L. DW. Control-Alt-Q.
Okay.
What? Okay. That's a little less weird. I see. Okay, I see what's going on now. Yeah. It's just your definition of Pandoric let's weird.
All right.
Oh, it's because you're using an and rest instead of an and body.
Oh, dang it. I'm sorry. Hold on, I'll fix that.
PLambda.
It's not your fault, it's his.
No. PLambda, not Pandoric let.
Yeah, no. We're translating a PLambda back to a Pandoric let.
Oh, I'm just saying his other one uses rest too.
Oh, yeah.
Shit. Okay.
Yeah.
Got it. Oh, yeah, and PLambda too as well. Oh, jeez.
Not your fault.
I swear.
There's just so much bad style advice presented by Doug. It's not even funny.
It's at some point I should just tell Doug, just correct your code so I don't have to worry about it. I think he put it at some point. Hold on, let me actually go in and do this.
Yeah, firstly, re-indent that code.
Nope, it's not actually liking that. It's now body. Good. 5L, 3L, DW.
Yeah.
There we go. Better.
Okay.
That works. It's just, it's being stupid.
Yeah, so re-indent that whole... Yeah, there you go. Cool. Yeah. It just needed to refresh the cache. Go up to the PLambda.
Okay. This one?
No. Yeah.
Okay.
Yeah, and re-indent that one.
Okay.
Re-indent the PLambda itself.
Oh.
Just do Control-Alt-Q on that.
Control-Alt-Q. Done. Okay.
Okay, yeah, okay, good.
This is good. Okay, and the difference is I mean, it's fairly subtle, but it's still the same, which is one is PLambda is actually generating our lambda function, and it's taking in the external environment as it's the list of variables from the external environment, but here, Pandoric let defines the environment.
Go up to the top of the file.
Okay.
Because there's something wrong. Scroll down, like Control-D.
What are you looking for?
The Pandoric get, the Pandoric set.
Here, it's right here.
Yeah.
So, if you want, I could split the screen, if that helps.
No. One of those is wrong.
Yeah.
Oh, yeah. The Pandoric set. You need an extra tilde A in the format string. You need another tilde A in the format string.
Ah. Yes. Okay.
Yeah, and recompile that. And yeah, now go down to the bottom and recompile. Recompile those two setfs. They won't have warnings now.
Ah, you're talking
There you
about that. Okay, got it.
Yeah, it was just irritating me.
That's fine. That's fine. That's perfectly all right.
I like code that compiles without warnings.
As do I, but I was going to go
Demo
look at
code.
that before checking it in. As do I. Live coding makes things like a little difficult, but
But anyway, so do you see how these two are similar in some ways and different in others?
Yeah, it looks like it's really the definition of how the environment's generating here, right? Like here,
Right.
it's being generated before inside by the Pandoric let. It's creating the closure, but we're creating the closure externally here. That's why he said it was an inside-out rewrite of Pandoric let.
Now, here's something that you can only do with PLambda.
Okay.
Head over to your REPL. Do let A be 0.
A0 B0. Okay.
No B, just A. You only need A for this one.
Okay.
And then enter or new line.
Dang it! I don't think
Alt J.
Alt Enter.
Alt J.
Alt J. Thank you. Okay.
Cool. Values. PLambda. N as the arg and A as the p-arg.
Oh, ANN.
Just A.
Okay.
As the second one.
Okay.
N is the arg and P and A. Because you need to give two. You need to give two things.
Oh right. So no, that's the first argument, and then I have to do this. A.
Yeah.
Okay. Got it.
Incaf A by N.
Okay.
And then close that, and then the second value.
Oh, you wanted another one? Okay. Hold
yes.
On. Okay. PLambda. Okay. Got it. What's the second
No,
value?
no. Outside of the PLambda.
Outside. Oh, got it. Okay.
Yes. Enter. New line. Yeah. PLambda. N A decaf AN.
Okay.
And evaluate that. Close all the parens and run. Cool. Now, here's the neat thing. Those two closures share an A.
Right.
You cannot do that with Pandoric let.
Oh wow. Okay. That's pretty cool. Okay.
Because with Pandoric let, the Pandoric scope is created around the specific lambda that gets created in the body.
Right.
Right? Whereas with PLambda, the scope can exist outside of the PLambda and gets captured by the PLambda.
Right. Okay, that makes sense. Actually, this actually introduces a nice way of creating essentially dynamic variables across multiple threads.
Kind of. They aren't really dynamic variables, but I kind of see where you're going with that.
You could do it.
Don't get confused with them.
I know.
This is all lexical.
It's all lexical, but
Doug mentions that he likes to think of them as blurring the lines between the two, but really, you can't. It's not stack based or anything like that. So.
Got it.
Don't think about it like that.
It's really what it is we have implicitly created an object with two methods.
Yep.
Yes, we did.
We just refer to it by the methods instead of by the object itself.
So we can actually...
And the methods have access to the scope, and we can access the scope through the methods.
Right. And we could technically pass these closures differently, but they'll still end up sharing the same the same state. So
you can do with Pandoric on either of them, and you're accessing the same A.
Yeah.
But they have different thises. That's important. Their thises are different.
Yes. Right.
But they share an A.
So it's like a class. Yep. It's almost like a class variable, then, right?
Kind of. It's kind of like a class variable. Kind of. But not really.
All right.
You can sort of think of it that way. If you think of those two PLambdas as like instances of a class, but that's a very kind of jamming a square peg into a round hole way of looking at it.
Certainly, but the analogy is still, I mean, it's very similar.
It's shared state.
Yes, it's shared state. That's what it is.
It's shared state among a group of objects.
Right.
But it's private. It's encapsulated shared state. And this is actually something you kind of can't really do with regular object orientation. The only way you could pull it off is with if you had two objects that both were passed a third object as one of their arguments to store in one of their fields, and then they access this shared state through that pointer to that third object.
Right.
But that's not really what we're doing here. We're doing something that's much cleaner and easier to follow.
Certainly, that makes sense. That's cool. That's really cool. And you can't. And the reason you can't do it with Pandoric Lambda is because of where the environment is being generated, right? It's
correct.
Because
because Pandoric Let, right? The body evaluates to a single lambda, and then it wraps that lambda to create the environment.
Right.
Right?
Mm-hmm.
And since it's a single lambda that you have to return there that gets wrapped, you can't share that environment among multiple lambdas.
Right.
But because PLambda captures the enclosing environment and turns that into a Pandoric environment, you can share it with multiple PLambdas.
But you could, I don't know, I could experiment with this, but couldn't you do something like this, though? Where you do, so this takes no arguments, but it returns values, essentially with two lambdas, that takes in an argument.
Those would no longer be the Pandoric lambdas.
Okay. Got it.
They would have access to the scope, but they would not actually be Pandoric.
They will not be Pandoric.
With Pandoric on them.
Okay, so those are not... So I'm basically, it's basically going, it's no longer a Pandoric macro. I mean, Pandoric.
It's no longer a Pandoric lambda. It's just a
lambda.
regular closure at that point.
Got it. Okay. All right.
Like, you could very definitely have that lambda return other lambdas, but those lambdas would just be closures.
Got it. Okay. That makes sense. Wow.
Although, here's something you could do. This would be a little weird, but you could have it return p lambdas.
Right.
And in that case, they would actually be capturing the environment and be Pandoric. It's just, at that point, why are you not just using let and PLambda?
Yeah, why are you... Yeah, exactly. Why are you using Pandoric let at all? I mean,
right.
It doesn't help.
Well, it sort of becomes a constructor for things that share this one particular bit of state.
Right. Certainly. Okay, cool. Well, that's Pandoric macros in a nutshell.
Oh, there's one more macro for them. There's the I forgot what he calls it. It's the defun analog.
Defun analog.
DefPan.
Oh, DefPan. Yeah, with Pandoric.
Oh, DefPan.
Yeah. DefPan is yeah. So DefPan, I forgot about DefPan. So DefPan is a very simple macro. It just basically defun and Pandoric kind of together. This macro, I mean, an example of it is like, let's say that you're trying to create, like, I think his example was using statistics. Like you could make like a dumb stats encounter. I'll just go ahead and grab this from his, give me a second here. I gotta go to his website to grab this. Okay. So his example is stats counter example from Let Over Lambda, chapter 6. So this is how it's being used. You might want to create like different types of statistics counters where you want to capture the mean, variance, and standard deviation. So you might end up doing something like this is crapping all the counts from the statistics for a particular variable, and then you can then create a function called, hey, let's create a counter that takes in the initial count, what are the initial sums, initial sum of squares, and then internally it will actually then call these def pans with Pandoric, which opens up, as you can see here, it opens up, grabs the sum and count from the function itself, and it will return what the mean, standard deviation, and variance are. So let's compile this and run this. So if we do a make stats counter, okay, and we say count is, let's say, 5. Sum is, I don't know, 0 to 2 initially, and then sum of squares is also 0. Okay, and let's go ahead and create a variable for this guy, test counter. And what? Sorry, did I not? Oh, not stats counter. Make noisy stats counter. Okay. So this guy, if we end up calling this guy, it's a closure. What was it? Oh, if we call test counter with 5, I think I have to use fun call here in this case. You'll end up seeing that we'll end up spitting out what the current mean, variance, and standard deviation is for that set. Nothing spectacular here, but we then have 2 additional things here that comes from Pandoric defpan, which is also the Pandoric eval. We have an equivalent to actually evaluate to eval for Lisp, but for Pandoric macros. So there is a Pandoric eval, and I'm going to post this, and then we can discuss what the code looks like, which is... So what does this look like? So this guy basically takes a set of variables and an expression, and it creates this, looks almost like a separate function, an anonymous PLambda, that takes in the variables and just returns true. But then it calls eval by opening up this Pandoric, what he calls a Pandoric eval tunnel, on the variables, and then evaluates the expressions in the second eval. Now, I honestly don't know, like, the example that he gave for this is the simple, let's grab this. Let me just compile this, and then I'm going to paste this here, and then just shift here. I think that's the correct notation. Okay. What this is doing is it's creating a lexical environment with x being 1, and then Pandoric eval grabs that x and then simply runs this s expression, which is currently quoted. It's not going to be evaluated until it gets into that with Pandoric. And what? It's there. It's inside the tunnel. So there is something going on here. 1 second. This is evaluated. I think he forgot a comma somewhere. Yeah, he forgot. I think the Pandoric eval tunnel is not comma. I think it has to be a comma here, right? I think so.
Yes, I think that's right.
So, yeah, this works.
Might even be quote comma.
It looks like it's working.
Huh. Interesting.
I could try quote comma, though.
No, that's probably not the right suggestion. nested back quotes always make my head spin a little.
Yeah. But this, when I read this, I'm still not entirely sure. But it says that, okay, so I don't know where to use this. Like PLambda, I understand, but
I don't think there is a particularly good use case for this. If I'm being perfectly honest, I don't think there is a particularly good use case for this. It's generating code at runtime and throwing it in eval.
Right, and that's usually a bit. When I see eval, I think code smell, but that's just me coming from other languages. I don't know.
No, you're totally right in that. Anytime you see eval and someone's not writing the REPL, they're doing something wrong.
I think code smell. I'm like, okay, somebody wrote something wrong here. I have to go and look at this and actually figure out how to actually fix it so that there's no danger. Okay, but if folks here are watching the stream, if you guys know of a good case where Pandoric eval is kind of like useful, let me know. But this is kind of a nice example that closes off. Like it shows that you can actually not only build up the Pandoric macros of actually opening up your lexical environment in a new lexical environment, but you can also create an evaluation strategy, which goes in and actually does the evaluation for you too as well. So this is completing the entire extension, so to speak, of Pandoric macros. We've gone through actually constructing them. We've gone through how to go from a Pandoric let to what he calls PLambda, which simplifies kind of also the declaration of the environments, allows you to use the Pandoric system like a normal Lambda function, and you create closures. And the difference between a normal closure and a Pandoric closure is nothing more than changing a Lambda to a PLambda. And then you have this ability to also create environments that takes in certain variables and evaluate them on basic expressions too as well using this. At this point, I think really we've kind of covered kind of the major topics, at least I'd like to discuss inside Let Over Lambda. There is a couple of chapters on efficiency that I'd like to get started on talking, but there's a couple of things I want to talk about before we go into those chapters. Because there's a couple of books that talk about Lisp efficiency in general. And some of them are kind of timeless. One of them comes from, I think, I don't know what your guys' thoughts are on this. Have either of you guys read Paradigms of Artificial Intelligence Programming? There's a chapter in there dedicated to writing efficient.
I keep meaning to do more than just
sure.
it.
Yeah.
Yeah. So I think at some point I wanted to bring up that book as something that we should start going into, just because AI is kind of like a personal favorite of mine, and writing Prolog and teaching how to do Lisp efficiency. I mean, that's kind of like one of the timeless classics, and it is available in its entirety online now. So thank you, Peter Norvig, for providing that gem for us to actually go through and study. On top of that, Doug's book on Lisp efficiency, there's this case study on Forth that I think we should at some point look at, but really it's really the Lisp efficiency stuff. As soon as I want us to start writing more applications and try to get you guys digging into actually doing some of this development stuff, which I hope some of you guys are doing. But that book, PAIB, has a chapter dedicated to Lisp efficiency that I think is far more thorough than Doug's section is. Doug kind of brushes off a couple of topics, but he doesn't talk about the dangers of consing a lot, which Norvig goes through in some cases in his book, but I don't know how much it applies to today. But
still applies a lot, actually.
Are there any questions from the folks here, Michael Gargano or Maris?
No, I'm good, thanks.
Cool. So until next time, honestly, I'm gonna give a couple announcements before I kind of end the stream. The week of July 4th. That's going to be kind of a holiday week. We are not going to have the study group then, due to the Independence holiday here, and me being out of town. But join us on July 13th. I'm gonna start promoting this a little bit more because we're going to be having Jack Daniel give an overview on PLambda, which is a very nice GUI library for Common Lisp. I'm hoping that it will be a very interesting discussion because I'm excited. I've been trying to get into PLambda, and I kind of understand how to write some basic applications on it, but it'll be great to at least hear if I'm doing it right or wrong, and go through that. Library suggestions, all more than welcome. Please give me library suggestions that we want to highlight because I'm looking for some more stuff to highlight. There's another budding list of topics for stuff that we're going to be going through. One of them is at some point is the Common Lisp type system, the meta object protocol, and a couple of other things. But hopefully we can take a break from book studying and show off some real code and highlight some really awesome things that are happening in the Lisp community. So suggestions are more than welcome. Post it on.
I actually have one. If at some point we can maybe just spend some time talking about like system programming, or even looking at a little bit at like MoveIts or Misano or something.
That will be interesting. Sure.
Oh, absolutely.
I don't know if any of us have a lot to say on that, unfortunately.
Systems programming is something that I've been wanting to get into as a topic, Michael. Unfortunately, I have to go and dig into Misano and MoveIts. At one point, I actually did dig into MoveIts and tried to see if I could get it to work, but MoveIts has been kind of, I think it's not inactively supported right now. I don't think it's being developed right now.
Yeah, I mean, even if we could just like, we don't even necessarily have to like dig into it in super detail, but just maybe having a conversation about the garbage collection and either running on bare metal or doing stuff at a system or OS level, and if there are any ways around that aside from basically writing your own Common Lisp implementation.
Would you be interested in writing like on stream, like going through and implementing a toy Common Lisp? Lisp implementation.
Yeah, no, that's a bigger undertaking than you're thinking.
Yeah. I started Common Lisp and then I was like retracting. Back. More maybe Lisp, a simple Lisp implementation, which will go through kind of what Common Lisp kind of would do, but then not entirely.
So,
I don't know.
So there are a couple different facets to what you're talking about there. System programming can mean a lot of different things. If you're talking about like just being able to access C libraries, we could definitely do a stream where we talk about
CFFI.
Stuff like CFFI and static vectors and all of that nice stuff. Auto-wrap or,
See, I will mention that CFFI is on my list of libraries that I want to highlight. It's just I didn't know at what point we should talk about it, just because I don't
think there's ever going to be a particular point in our stream where CFFI makes more sense to talk about because it's kind of orthogonal to everything else we're discussing.
Right, but it is something kind of useful to know at least.
Oh yeah, no, I agree that we should eventually get to it. I think my point is just that I'm not sure that there are any actual scheduling decisions to make other than do we have some free time and nothing else better to review.
I would actually, point everyone to Bagger's stream on CFFI since he covered it so thoroughly.
I totally agree with that. Baggers did a really good CFFI stream.
I did not realize that. So Baggers, I apologize. I should check that stream out to figure out what's available. Go to Baggers' stream.
Yeah, I think it's like a 2-hour stream. I mean, he covered it pretty thoroughly, and if I'm not mistaken, he did another one recently.
I think
he's been doing some pretty good low-level stuff. Like honestly, Baggers, has been doing a lot of really good interacting with C-level stuff. So there's that. There's interfacing with C-level components from Common Lisp is one aspect of sort of the idea behind systems programming. Another one is like understanding what's actually going on inside of an implementation of Common Lisp. And at that point, we start talking about, okay, which implementation do we want to actually be looking at? And the answer for me would be SBCL, just because that's the one that I, have any kind of understanding of the internals of, at all. I know a little bit about what's going on inside of Sickle at a very high level, and I know a little bit about what's going on inside of ECL at a high level, but and I suspect I'm not the only one who can say this. The one that we use most, and so the one that we develop the most intuition for, is SBCL.
Yeah, I would actually agree with that. SBCL seems to be the most, at least for my use cases. I think it's probably the same
Linux.
for DJS on Linux
on
as
Linux.
Yes, of course.
CCL is much more common on Windows and Mac.
Yes, this is true.
Really, I would have suspected.
SBL has, there's actually a big fat warning when you start up SBCL on Windows saying that threading support is very experimental and they don't have any desire to continue working on it or something like that.
Something along those lines, yes.
Yeah, because there isn't
and
really
CCL is just flat out designed to run atop OS X. CCL has Objective-C bindings, and that's kind of unique in the Common Lisp world. So CCL is a bit more cross-platform than SBCL. So, as I said, another aspect of talking systems programming is actually discussing details like how does an implementation optimize allocation, accessing stuff, what kinds of optimizations can it do during compilation, how does garbage collection actually work in practice. Some of that we can get into, some of it isn't really Lisp specific. A decent chunk of it is just talking about what it means to be working in a hosted language, in a managed memory language, and then we can of course talk a bit about what does it mean to run Common Lisp, on the metal, I suppose you could say, as a ring zero, calling it an operating system. In the modern sense is kind of funny, in my opinion, because it's harder to draw the line between where the OS stops and where the user level stuff starts.
But I would argue that Common Lisp, the way it was designed at the time, right, it took a different approach when operating system research was very active on what the notion of an application is. And that
I totally agree.
And that really needs to be at least stated in some sense when you talk about systems programming in Common Lisp. What is the notion of an application in Common Lisp? Well, that for most intents and purposes, the way I at least experienced it in various Lisps is that the notion of an application is kind of a library, it acts the same way as a library. You open it up and you instantiate a function, and then the application kind of just shows, it just instantiates itself as a separate object inside of your image. But those details.
When you're talking about Lisp on the metal, that's very much the case. Just about all of the Lisp operating systems, all the ones that I've looked at, go that route.
And that's actually the same, by the way, Michael, for Mazzano, as I understand it. I don't believe it's still a single Lisp image where applications
right,
are...
Yeah, as far as I understand it, basically what they had to do is from my understanding of the two of them, is that they basically implemented their own CL, basically so that you could have basically the garbage collector, right, running on the bare metal, and then everything that you're doing on top of that, you basically have a garbage collector and a REPL, and then you just lay everything on top of that, basically.
Sort of.
And I was just wondering if there were other ways that were easier, short of doing something like that. I mean, it seems like that's probably the easiest way, but I know LispWorks and some of the commercial ones allow you to do some embedded stuff, and I'm sort of interested in that area a little bit. And it'd be nice to use Common Lisp, but for using SBCL or something like that, obviously you can't do that because it,
Michael, have you read ClassOS, the paper by Robert Strand?
not the book, right? The paper.
It's a paper.
Yeah.
I mean, it goes into explain how, like, I think it compares the Unix operating system, or Linux these days, with the Lisp OS, and tries to, give a whole different model of how to do it, because it really doesn't fit Lisp, common Lisp language at all. The modern, idea of an operating system. So much has to change at a fundamental level that it's not even funny to be, implemented properly.
Like, I think the book that you're mentioning is the recent publication. I'm forgetting who the author was on Lisp system implementation. The guy wrote actually a similar thing but the one that Michael is referring to is actually a white paper that Robert Strand published. I think a couple of years now.
Yeah, it's been a little while.
6 years.
Yeah.
2013.
6 years. But it gives you an idea on, well, if we were to design a Lisp system that truly is like, a testament to Lisp and have some of the, the features that we love from Lisp, but at the same time has some sort of like memory boundaries and things like that, this is how you would approach designing such a system. And he comes up with a couple of requirements, which I thought was really nice. And I think a couple of people attempted it. In Mazzano's case, I don't think that's what they did. They actually,
not really, no.
Yeah, they took a different approach, a valued approach, and I think it's a time-tested approach when it comes to writing common Lisp.
Basically went the genera route.
Yeah.
Like, this all sort of goes back to genera when you really start digging into it. It all eventually, all of the Lisp OSs that I've seen and I've actually been used to practice basically have all gone the genera route. All the ones that I've looked at, which basically is you build a Lisp environment that runs without any containing operating system. It runs directly in ring 0, or, well, in Genera's case, there weren't no ring levels because it was running on, Lisp-specific hardware. But it's running at the lowest level of the system, and it just manages everything itself. It's got a garbage collector that's running, and it's got Lisp code that's running, and it's just kind of doing its thing, and it's all one system. Saying that you start with a garbage collector and a REPL is probably not the right way of putting it, because Mezzano in particular boots directly into a graphical shell.
Right.
Right. It boots. When you start it up, what you have is like a desktop with icons and windowed processes, but it's still...
Right, but essentially, like, there's an independent, right, you basically re-implemented C, because I know that this is the way that Hotpatch pretty much works, right?
It's a full implementation of Common Lisp that's been built to work out of, without the need of any containing OS.
Yeah.
Correct.
So for embedded systems, I think the recommendation, outside of taking the Mazzano approach, is at least the lowest hanging fruit, right? The easiest way to do it is, I think, ECL.
I don't even know if you could do ECL embedded. I don't know how that would work.
You would have to have a small
ECL,
C core that boots into ECL, right? And then you use ECL with a kind of like a C like shell outside of it to interact with your system.
Yeah. ECL can do raw C stuff, right?
Right.
And it can be cross-compiled. But even ECL does OS, it expects an OS around.
Right.
It expects to be able to make POSIX calls. And so I don't know if you could just take ECL and just stick it on an embedded device and have that work, because I don't exactly know what would happen, because I don't know enough about ECL's cold boot procedure.
Right.
So that when it's setting up its initial environment as your process launches, I don't know if it actually needs the OS to be around, or if even trying to load its shared object is going to be hey, why don't I have an open function I can call? Right? there's a lot of stuff that's just missing in an embedded environment, and I don't know, how ECL will handle that stuff just not being there, even if you don't use it yourself in your code.
So I will point one thing out. I'm also kind of interested in this particular area, and outside of Robert Strand's white paper, the other one that came up with some ideas on, at least that influenced my thinking on systems programming, common Lisps, and if one were to build one, what route to take, goes all the way back actually to something that Richard Gabriel posted in his Worse is Better series, like the first paper that introduced Worse is Better. Like towards the bottom of that, which was Lisp, the good, the bad, and how to win big. There's a section where he goes, if we were to do this all over again, try to figure out the best way to get a bare metal Lisp running on the system, like almost scheme-ish, and then build common Lisp on top of it. And I think that's the kind of approach that Movitz took. Mazzano took a completely different approach, of course, but that's another route that we can, certainly, discuss. But in terms of suggestions and recommendations, I certainly am not the right person to actually to suggest how you would actually go about and design an embedded system using Common Lisp. I'm sure LispWorks and even probably Franz gives you some suggestions on how to do that.
Write an implementation in MicroLisp.
Oh God!
It already runs on Arduino and everything else.
Right, exactly. That's certainly a good start, right?
I don't really recommend that, but it's an option.
It is an option.
Part of the trouble is that Common Lisp is built in a lot of ways under the assumption that you're running with an operating system. So running Common Lisp in an embedded environment, I don't know
requires a lot of memory too, which you're not going to have.
You can get around the memory requirement to some extent. Not extremely, but to some extent you can get around the memory requirement.
Oh, sure, definitely for bootstrapping. But beyond that,
yeah.
I mean, is it practical to use?
My point is more just that that it wouldn't be Common Lisp. It might be Common Lisp adjacent. It might share a lot of similarities with Common Lisp. You might even be able to share a lot of code between them. But a language that's Common Lisp-like but runs on the metal would, just like there's an embedded C specification, not be Common Lisp. It would be like embedded Common Lisp or something along those lines. I mean, like ECL, kind of, but, designed so that it doesn't even have things like an open function that it exports, because what are you opening? You're on an embedded device, and maybe it exposes things that aren't, accessible in a regular Common Lisp environment that you would need on a kind of embedded system. But it would be a slightly different language. Any Common Lisp implementation that's designed to work on a embedded system would have to really stretch some of the requirements of the spec to actually be compliant.
I mean, but in a way, that's like saying you can't write an embedded system in C because it has an open function, right? So,
right.
I mean, if you're writing an embedded system, you just don't call into those libraries.
So with
right. Well, so the problem.
I'm going to take a step back here, if I can interrupt for just a second here, regarding C specifically, just because I've dug into this, and with C, there's actually a clear definition of what they call a hosted environment version of C and a freestanding environment. Of course, most people who are familiar with C know it from the hosted environment standpoint, which is open, close, a lot of the standard library functions. But you could write C without actually dealing with all that by using I think it's like 6 or 7 standard headers, which only defines the data types, the basic data types of the systems, and how to define functions. And of course, you won't have a runtime there, you won't have malloc, you won't have any of that. You have to write all that from scratch. In terms of Common Lisp, I've never actually seen kind of an adjacent, kind of a one-to-one, like how would you bootstrap the system, in a very clear, small subset, and then build up the system from the ground up. And I think that's kind of the point. Like, Common Lisp was designed with the expectation that there is some sort of hosted environment that's there. All the functions and operations are built on top of that base.
Yeah, I feel like Mezzano, for example, is this interesting case because it's actually bootstrapped. It's got what's called a cold boot procedure. And actually, I mentioned this earlier when I was talking about ECL. ECL, every common Lisp actually has has cold boot and warm boot, and you tend to only interact with one of those, generally speaking. And I was possibly abusing terminology earlier when I said specifically ECL doing a cold boot, but the difference really is that in a cold boot step, you're loading everything sort of from scratch, whereas in a warm boot step, you've got you've already pre-built a lot of your Lisp environment and you're mapping it into memory. Like a lot of this sort of terminology that only makes sense when you're talking about like an image-based common Lisp, but most of them are. A cold boot is where you don't already have an image; you're building your initial image, and a warm boot is when you're just loading that already pre-built image and then you're extending it. You're building atop that. So Mezzano actually does a cold boot process, and it uses SBCL as its bootstrapping compiler for its cold boot process. Because of that, it's able to have a whole lot of code that's written in Common Lisp that runs during its cold boot process, and then have its actual runtime code also be written in Common Lisp. And it kind of sidesteps the fact that it doesn't actually have, it's not able to use its own Common Lisp compiler during the cold boot process, but it still has full Common Lisp code during cold boot.
But that illustrates the point, right? Which is like if you want a pure Common Lisp, like turtles all the way down system, you still need some sort of bootstrapping compiler to start to the core system itself. And if you and that may be a third party Lisp, but that third party Lisp, if you're going to use something that is not your own from the ground up bootstrap compiler, that expects a hosted environment, at least for the majority of the Lisps that are actively being used today.
And so like like if you do a hosted Lisp, you can either do it where it's not image based, in which case every boot is a cold boot in a sense, right? Because it has to build the entire layout of the system, has to build out the entire initial state of the memory, has to basically bootstrap everything every time you launch the system, right? Because there's a whole lot of bootstrapping nonsense that goes into making any Common Lisp environment actually usable. That's just kind of because of the way the spec is designed and because of like how the meta object protocol works and all of that stuff. Every time you boot a Common Lisp environment, every time you cold boot a Common Lisp environment, there's a whole lot of bootstrapping meta-circular nonsense that has to go on in order to get everything working properly until you get to a self-consistent state and you can run regular Lisp code. And so if you're running a Lisp that's not image-based, you end up doing that bootstrapping step every time you launch the system. And I don't know for certain, but I think that's how ECL works. I could be wrong. It's also entirely possible that they just dump out compiled C code that just already, like, they dump out object files that just already have a pre-booted image.
Well, we could ask him about it.
Yeah, that's true. We could ask Jack Daniel about it
for the McClim show.
Yeah, because fun fact, Jack Daniel is also the ECL developer. Though surprising him with questions about ECL when he's expected to talk about McClim may not be the nicest thing to do.
Right, but we can certainly ask him, to give a separate discussion about ECL.
Oh, sure. I mean, we could definitely ask him for that. Another thing, I don't know if Froggy would be interested in this, but it's possible that Froggy would be up for dropping by the virtual study group at some point to talk a little bit about Mezzano.
Yeah, I think it would be great.
He's on IRC from time to time. I'll ask him if I see him.
He's Mezzano has an IRC channel.
Yep.
So he's on there fairly often.
He's also squatting in the Lisp chat room. I see him periodically in the Lisp chat room as well. Yep. So asking him and certainly.
But yeah, I guess my point is that future sessions talking about systems level Common Lisp, there are a couple different ways to approach it, and I think the people who are currently on the call are only knowledgeable enough to talk about some of them.
Yeah, I
my
can.
point. Like,
I won't say that we know
the
everything.
internals of SBCL, we can dig into that a bit. If we start talking about Lisp on the metal or like embedded Lisps and stuff like that, I think we all need to defer to people that are actually doing this right now.
Yeah, and and certainly, at some point, highlighting those systems would be great, and I think a lot of folks would enjoy that. But in general, there's like JS and Elijah and Michael were pointing out. Systems programming is itself an overloaded term when you talk about day-to-day use. When it comes to Common Lisp, it just gets that much more murky just because of where you want to. What do you mean?
I mean, when I think of systems programming, I think about programming with extremely constrained resources.
Right. So
and in a hosted language with dynamic, everything's dynamic. That it kind of makes it murky, like you said.
Yeah.
Like, what exactly does it do?
I mean, Python and Lua and all these where people are using are doing embedded systems work. At the heart of it is still Linux, like a lot of it, because they expect it that way. And in many cases, Common Lisp is kind of in that same family in terms of its approach to dealing with the embedded system stuff. But with the Mezzano effort and people who, if we can actually revive MoveIts at some point, which it would be a dream. Those take a different approach than to what systems programming is, and that's actually building an operating system, and which effectively is building a Lisp implementation from scratch. So
I mean, it's both really. It's both building an operating system and a Lisp implementation from scratch. You actually have to build the OS first,
right?
Because you then need to build the Lisp implementation out of that. And that was why I was kind of getting into the whole metacircular nonsense about how Mezzano's boot process is written, its cold boot process is written in Common Lisp, right? Because it has to compile all of the assembly that then at runtime can bootstrap the OS.
Well, it's funny you mentioned that because that's what...
so you got to write an OS before you write the implementation.
Right, but you also have
to... I started learning Common Lisp, I'm still learning Common Lisp, so I don't see...
Right.
myself being capable of that anytime soon.
With Mezzano, right? And it's possible that I've misunderstood some of this, but my understanding of digging into it to the level that I have is that with Mezzano, the basic system is written in Common Lisp, right? Like everything is either written in Common Lisp or like inline assembly, right? But the way I'm imagining it must work is that he compiles Mezzano's compiler with SBCL. He loads it into SBCL. Then he uses that to compile the actual OS to generate the cold boot image so that he has raw assembly for that. That's all in the right actual physical memory locations. And then that's actually an OS.
That makes
sense.
Then
can compile the actual Common Lisp implementation and load that into the image as well and dump all of that out as a file. And then you can map that onto a drive and boot it.
Yeah.
Right?
I forgot which implementation, but one of them, it might even be SBCL, cold boots itself with C-Lisp.
Yeah. I think SBCL does.
Or did at a time.
Yeah, SBCL can cold boot with any implementation. SBCL can actually cold boot with anything. It's kind of neat. I've read the SBCL bootstrapping procedure. It basically does the same thing that Mezzano does. It actually when you need a new version of SBCL, you compile the new version of SBCL with another Lisp, and then you use that to compile SBCL again to generate all of the facils. And then there's a process, I think it's called the Genesis process, which takes all of those facils and turns them into a cold boot image, which can then be loaded, and then a whole lot of bootstrapping metacircular nonsense happens in that final load step to actually take you from this, halfway there cold boot image to a completely there fully booted image, and then they dump that out using effectively the same save Lisp and die process to actually just make the full warm boot image that they distribute.
Fun stuff.
Yeah.
Yeah. And so I imagine Mezzano must basically be doing that same thing. It's that they compile the compiler with SBCL, and then they use the compiler to recompile the compiler and the operating system and their Lisp implementation and build an image out of that.
Yeah, no, I
And
think
then they boot that, and then it does some final initialization procedures, and then they can save that. And it's
craziness. Jeez.
yeah, it's mind bending the amount of work that goes into actually cold booting a Lisp system. It's really crazy, but I mean, you can do it, and that means that the whole thing can be written in Common Lisp. The cold boot process can be written in Common Lisp.
There was a talk, I think, from I think last year by Dr. Meister for Clasp, and how he ended up writing essentially his first version of Clasp, which is actually BLASP, was originally written in his way. It was slow, but it was written completely so that it will generate LLVM, and then he used that as a bootstrap to Cleaver, which is from Cycle, I think. Sickle. Yeah. I don't. And that actually ended up becoming Clasp. Clasp is basically Cleaver recompiled.
It's pronounced Sickle because the other part of the project is Cleaver.
Oh, okay. Oh, right. All right. Got it. Okay. Got it. The puns.
That's how you know it's pronounced Sickle.
Sickle and Cleaver. The end. It's still the same thing. They bootstrapped a compiler. They wrote the bootstrap compiler in LLVM and then used that to compile another compiler to LLVM.
Yeah.
So I don't think you can run away with not writing a bootstrap Lisp system, or getting an existing Lisp system.
The difference, of course, is that whenever you bootstrap a Lisp implementation, you have to compile the compiler with the old version and then compile it with itself as kind of one big step at runtime.
Right, exactly. And
it's like you load the compiler into the runtime with another compiler, and then you use the API for the compiler you just loaded to compile itself.
It's a bit of a Inception sort of thing, man. Like at the end of the day, though, you'll have a really fast.
It's a compiler compiled by a compiler, so you can compile your compiler.
My brain just tied in a recursive knot.
Right.
I mean, that's true of every compiler, but in this case, it's all in one process happening at runtime.
Yeah.
That's the difference, is that in a Lisp world, all of this happens in a single process at runtime. And it's not the only way you can do it. A lot of other Lisps actually bootstrap by basically side-effecting their image, right? Which I consider all kinds of crazy. But what they do is they start with a previous version of their system, right? And then they side-effectingly modify it in place till it gets to the way they want it to be, and then they save that new image out. And every time I hear about that, I'm like, how the heck do you cross-compile? What are you doing? How do you make it, you've just limited so many... Anyway.
Yeah. Bottom line, it's a very, very deep subject, Michael. But we can go into it in separate layers. I think it's a good idea to bring up in some of this. If we can get Mazzano's, Arthur Froggy, and Jack Daniel to talk about some of their implementations on this would certainly help guide the discussion. Yes. But in terms of interacting with using CFFI. I've done a little bit of that. But I would recommend you going to Bagger's stream.
We can definitely revisit CFFI on here, as our sort of own take on it, I guess. But Bagger's definitely covered all of the actual API stuff and
if there's something in particular,
it's a really great walkthrough, honestly.
Yeah, if there's something in particular,
good. So whatever we. I'm interested in all of that, so whatever we touch on would be great.
Okay, cool. All right, cool. We'll certainly get into that. So until next time, thank you guys for joining, and I'll see you guys next week.
See you then.